Let's do another practice problem. So this is a follow-up problem from the problem that we have for the customer satisfaction problem. Given the average of 72 and a standard deviation of 12 for customer satisfaction, and that is following the normal distribution, what is the 90th percentile of our customer satisfaction? So please pause, think about this question and try to answer it, and then come back to see the solution. Let's see the solution. So this question, we know that X follows a normal distribution with an average of 72 and a standard deviation of 12. So what we are looking for is, we know the probability that X is something is equal to 90%. This is how you would translate this problem. 90th percentile. That means that the probability that X is less than the value that we are looking for is 90%. So this is an inverse problem. We have the probability we are looking for X. So we're going to follow the steps to solve this problem. We're going to first find the Z of X and then plug it in the formula. So Z of X is, if you find it from the table for 90th percentile, is 1.28. Having 1.28, if you plug it in this formula, we're going to get mu is 72 plus 1.28 multiplied by 12, which is standard deviation, and we get the X equal to 87.36. So this means that 90% of customers, we would expect 90% of customers to gives us a satisfaction score less than 87.36. Practice problem. In 2008, the per capita consumption of coffee in the United States was reported to be 4.2 kilogram or 9.24 pounds. Assume that the per capita consumption of coffee is approximately distributed as a normal distribution, with an average of 9.24 pounds and a standard deviation of 3 pounds. What is the probability that someone in US consumed more than 10 pounds of coffee? So please pause, solve the problem, and then come back to see the solution. All right, let's see the solution. So here we have a normal distribution. If X is the per capita consumption of coffee in the United States in 2008, according to the problem, this would follow a normal distribution with an average of 9.24 pounds and a standard deviation of 3 pounds. So the problem, part A, would ask for what is the probability that someone in US consume more than 10 pounds of coffee. So that's the probability that X is greater than 10. So this is easy to solve. What you need to do is you convert this to the Z distribution and also convert that to the 1 minus the probability of less than that, and then we will get our solution. So this would be the probability of 1 minus the probability of X less than 10, and then we convert this to the Z distribution, minus probability that Z is less than Z of 10. Then we look for that value in the Z distribution table. So the probability is 40%. Follow-up question. What is the probability that someone in US consumed between 3 and 5 pounds of coffee in 2008? So please pause, work on this problem, and then come back to see the solution. Let's see the solution. So here we are dealing with the same problem. X, the random variable X represents the per capita consumption of coffee in US in 2008, and it follows a normal distribution with an average of 9.24 pounds and standard deviation of 3 pounds. The problem is asking us to find the probability that X is between 5 pounds and 3 pounds. So what we need to do first is to convert this to the Z distribution. So that would be the probability that Z is less than Z of 5 and greater than Z of 3. And then we subtract the probability of z less than z of 3 from the probability that z is less than z of 5. The probability of z of 5, the z of 5 is negative 1.413 and z of 3 is negative 2.08. The probability of z of 5 is 0.079 and the probability of z of 3 is 0.019. So we subtract the probability that z is less than z of 3 from the probability that z is less than z of 5. And that gives us the final probability, which is 6%. So the probability that x is between 3 and 5 is 6%. Follow-up question, part C. What is the probability that someone in US consumed less than 5 pounds of coffee in 2008? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So this is easy. What we are looking for is the probability that x is less than 5 pounds. And we know that x is a normal distribution with an average of 9.24 and a standard deviation of 3. So we would convert this to a z distribution first. That would be the probability that z is less than z of 5. And then we look for z of 5 in the table and we find the probability. So z of 5 is negative 1.41. And if you look at the table, that's equal to 0.79. So the probability that someone is consumed less than 5 pounds of coffee in 2008 is 0.079. Follow-up question, part D. 99% of people in US consumed less than how many pounds of coffee in 2008? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here we have the same random variable x. Random variable x is normally distributed with an average of 9.24 pounds and a standard deviation of 3 pounds. What we are looking for is, we know the probability is 99%. We want to find x such that the probability that the per capita consumption is less than that value is 99%. So this is the inverse function. We have the probability, we are looking for x. What we need to do is, first we're going to convert this to the z distribution. So we know that the probability is 99%. We are looking for z of x such that the probability that z is less than z of x is 99%. After we find the z of x, we can find x. Using this formula. So first we need to find z of x. The probability that z is less than z of x is 99%. If you look for in the table for 99%, it corresponds to the value of 2.33. So that's z of x. If you plug z of x here in this formula, you get x, which is equal to 16.2. So 99% of people in US consumed less than 16.2 pounds of coffee in 2008, which you can actually check this probability. The probability that x is less than 16.2 is equal to 99%. Follow-up question, part E of the problem. 75% of the people in US consumed more than how many pounds of coffee in 2008? So please work on this problem, pause, and then come back to see the solution. Let's see the solution. So here we have the same probability distribution, a normal distribution. So X is the per capita consumption of coffee in 2008 in US. That's normal of 9.28 pound of coffee and 3 the standard deviation. What we are looking for is, we know the probability is equal to 75%, and we are looking for x such that the per capita consumption is greater than that value. The probability would be 75%. So to solve this problem, the first thing that we need to do is to convert this to z distribution. So that would be the probability that z is greater than z of x. We know that the probability is 75%. So before we move on, we need to convert this to less than probability, because this is how the z distribution table work. It's for less than probability. So to do that, we know that if the probability z is greater than z of x is 75%, this means that the probability of z less than z of x is actually equal to 1 minus 75%, which is 25%. Okay, so now we can look at the z distribution table and we can find the z of x such that the probability is 25%. And then we can plug it in the formula. This is the formula. X is equal to mu plus sigma multiplied by z of x. And we find x. This is the formula. Let's find z of x. So z of x is negative 0.68. So we plug it in this formula and we find x. And x is equal to 77.2. We can also use the Excel to find this. So that would be norm.inv 25%, 9.24 as our medium, as our average, and 3 as our standard deviation. So if you remember, another name for the normal distribution is Gaussian distribution, and that's the name of Gauss, the German mathematician who actually is one of the most influential figure in mathematics, physics, and statistics, who came up with the normal distribution. So before Germany moved to the euro currency, the only currency used to be mark. And to honor Gauss, they had his picture on their currency. This is Gauss, and if you look closely in the middle, you can see actually the normal distribution. And this is the function, the probability density function for the Gaussian or normal distribution.